Hello everyone, this video covers a couple of the basic calculations and types of questions you may get on the chemistry exam. This first question covers two concepts you need to know. First of all, how to identify the relative atomic masses and relative formula masses, and secondly, how to calculate the percentage mass of an element in a compound. To find the relative atomic mass of an element, you look on the periodic table, locate the element, and then look at the number at the top. To find the relative formula mass, you find the mass of each element involved. In this case, you have magnesium and oxygen, and then you add together the masses, and that gives you the MR. To calculate the percentage mass of a compound, you would use the equation of the percentage value that you're trying to find divided by the whole amount, and then you would multiply by 100 to convert it into a percentage. So in our question we can see that the percentage value that we're trying to find is magnesium, and it's given to us here, which is 24. So we would do 24 divided by the whole amount, which is the MR of magnesium oxide. So divided by 40 and then times by 100. Put that into your calculator and we get an answer of 60%. Always double check they've included the units on the answer line. If they haven't, then please make sure you go ahead and include the unit. The second type of question is to calculate either the number of moles, mass, or MR, using the equation that we've taught you, which is mass equals moles times MR. So start off by bugging the question, which means you use the B to box off the command, and in this case it's asking us to calculate the number of moles. The U stands for underline any of the other important information, and in the question it tells us that a bag of fertiliser contains 14.52 kilograms of ammonium nitrate, which will need converting because we calculate mass in grams. And it's given us the relative formula mass for ammonium nitrate, which is 80. So we don't need to work that out. Whenever you're doing a question like this, always use the every method, which we have taught you to use throughout Key Stage 4. So first off, start by writing in the equation. Mass equals moles times MR. The value of our mass is 14.52 multiplied by 1,000 to convert it to grams, so that becomes 14,520 grams. The moles we're calculating, and the MR has been done for us, which is 80. Right, we then go on and rewrite the equation with the substitution. So we have 14,520 equals moles times 80. In order to make moles the subject of the equation, we can simply divide 80 by 80, hence cancelling that out on that side, and what we do to one side we have to do to the other. And so therefore when we put that into our calculator we get an answer of 181.5. Now the question says give your answer in standard form to two significant figures. So we need to rewrite this with just two significant figures, and so that means if it's in standard form, therefore it's got to be times 10 to the power of. So 181.5 in standard form to two significant figures equals 1.8 times 10 to the power of 2. You can see that we've simply moved the decimal place back 2 places for our two significant places and rounded off. There will always be a question on concentration, and sometimes it will ask you outright to calculate concentration, or other times it might ask you to calculate one of the other variables. And in that case, you then have to work out it is actually a question about concentration. You can generally work out it's using the concentration formula by the information given in the question. And in this case, it describes a solution with a solute that's been dissolved in litres cubed. And that's generally the thing that leads me to the fact that it is a question on concentration. So with any kind of calculation, we would advise that you use the every method that I've already written in here on the slide. And secondly, try to remember the formula for calculating equation as concentration equals the mass divided by the volume, and then you can manipulate it further down in the question, and by showing your workings out you will always guarantee that you will get some marks even if you make an error throughout the calculation. Always start off by bugging the question, and that means to box off the command of the question. And this question, the command is asking you to calculate the mass of the solid copper chloride that was dissolved in the liquid to make the solution. Underline any of the other important information. Now it tells us that they used copper chloride solution with a concentration of 300 grams per litre cubed. dm cubed are the units of a litre, decilitres. And we've also got that the student used 50 centimetres cubed of copper chloride. Now we can see from the formula that we use litres cubed rather than centimetres cubed. So that's our cube that we need to convert that before we can get our answer. So E, of course, stands for the equation, which is concentration equals mass divided by volume. The V in every stands for the value of the variables. So for our concentration, we can tell from the question that it is 300 grams per litre cubed. Always include your units. It's asking us to calculate the mass, so put in our question mark, and then the volume of our solution is 50 cubic centimetres. Now, as I said, we would need to convert that, and in order to convert from cubic centimetres to decilitres, we need to divide by 1,000. So you can pop that into your calculator and we would get 0.05. The second E stands for the equation with substitution. And so this is where we now put our numbers that we've identified on the V line into our equation. So we have 300, because that's the concentration, equals the mass divided by 0.05. Now, in order to make mass the subject of the equation, all we need to do to show this manipulation is that we can multiply 0.05 by 0.05, effectively cancelling it out there. And of course, what we do to one side, we would do to the other side. So I'm going to rewrite this in a better format. So mass equals 300 times 0.05. Put that into your calculator, and the answer on the answer line is then 15 grams. Again, just make sure they've included the units, and if they haven't, make sure that you put in the correct units. I've included this question in order to recap some of the basics of electrolysis and redox reactions from the chemical changes topic. If you remember, in the first part of this topic, we looked at what we meant by redox reactions. And redox reactions was where we used the anonym oil rig. And oil rig stood for oxidation is loss of electrons, reduction is gain of electrons. And that's how we explain how ions are restored to atoms during electrolysis. Electrolysis is where we use electricity to separate a compound, and it includes the use of two electrodes, one of which is positively charged, which attracts negative ions, and at the positive electrode, that's where the ions are oxidized, and then on the negative electrode, that attracts the positive ions, and that's where they are reduced. The positive electrode is called the anode, and during electrolysis, any of the ions that are attracted, which are obviously negative, are oxidized, and of course that means that they lose their electrons, and in losing their electrons they then are restored to neutral atoms. On the other electrode, the negative one, this is called the cathode. The cathode attracts positive ions. Once they are attracted to the electrode, they are then reduced. And of course, if they are reduced, that means that they gain the electrons. And once they have gained their electrons, they too are then restored to neutral atoms to be discharged. Secondly, the other rules associated with electrolysis are which atoms will be discharged at the electrodes when you have a solution. And in any solution, there are always 4 ions in the solution. So firstly, at the anode, the rule is that if there are halogens present, such as chlorine, bromine or iodine, they will be the ones that are discharged. If there are no halogens, then it will be oxygen that's discharged at the anode. On the cathode, this is of course the electrode that attracts the metal ions, and if the metal is more reactive than hydrogen, then hydrogen will be discharged at the cathode. However, if the metal is less reactive, then it will be that metal that will be discharged at the electrode, such as copper, zinc, any of those that are not in group 1 or 2. Now, this question specifically asks you to which gas is produced at the positive electrode or the anode. So having recalled that basic information about electrolysis, you can quite easily pick out from the selection that you've been given. Carbon dioxide wasn't even in the question, so it's not going to be that one. And of course, if it's at the anode, then it's going to be the negative ion, and the only negative ion that you've got there is going to be chlorine. And then on question B, copper is produced at the negative electrode. What does this tell you about the reactivity of copper? We've just written out our rule here at the bottom, and we know that if it's less reactive than hydrogen, then it will be discharged, and so therefore copper is less reactive than hydrogen. Aspects of these last 2 questions always crop up on paper 1, where they ask you to either describe or explain ionic and covalent bonding, or show the dot and cross diagrams. This question is about ionic bonding, and you can tell because the opening line tells you that it includes magnesium ions and chlorine ions, and it's only in ionic bonding that we actually have ions with differences in charges. In order to answer this question, you would firstly need to be able to explain how atoms become ions, in that the metal atoms will lose their outer shell electrons, and the non-metal atoms will gain those extra electrons to become negatively charged ions. And then once you've stated how you've arrived at the charges on the ions, you would then need to explain how that dictates the formula of the compound. And of course, that's how the ions need to balance to cancel out the difference in charge to make a neutral molecule. Thirdly, you would need to state the type of forces between the ions, and then finally you would need to include what type of bonding it is, which we've already said we know it's ionic because you've got the difference in charge of ions. I would start out this question by firstly stating how you arrived at the charges on the ions, and we know that magnesium will lose its two outer shell electrons to become magnesium 2+. That's because it has more protons now than electrons. And then chlorine, being a non-metal, will gain an extra electron to get a full outer shell. And so in this case it becomes Cl negative because it's got now one more extra electron than proton. I would then go on secondly to say that in order to get the formula of magnesium chloride, you would need one magnesium ion and two chlorine ions. Obviously you would need two chlorine because they only have a charge of 1, and therefore your formula for magnesium chloride would be MgCl2. I would then go on to say it was the electrostatic forces of attraction between the oppositely charged ions, and of course that was an ionic bond. So always make sure you include those various things in a description of an ionic bonding: how you arrived at the charges and how atoms change to ions. Secondly, what would be then the formula of your compound and how it's the balance of plus and negative charges. Thirdly, with any ionic bond, it's the electrostatic forces of attraction between the ions. And so hopefully then you would be able to achieve either the 3 or 4 marks. Finally, this is a classic question where you are required to firstly identify it's a covalent bond question, and you can tell because it's got two non-metals in the question, and also in the diagram you can see that the shells overlap. And secondly, in order to answer this question, you need to remember the rule for covalent bonding, which is that the atoms share pairs of electrons. So always remember to plot them out in pairs when you're doing the diagram. During a covalent bonding atom diagram, you've got to show where the atoms are trying to achieve a full outer shell of 8 electrons. So first of all, start out by working out how many electrons each of the elements involved needs to achieve a full outer shell. If we first look at chlorine, we can see in the question it tells us it has 7 electrons in the outer shell, and we can work that out anyway even if it doesn't give you in the question, because we know it's in group 7, so therefore it has 7 electrons in its outer shell. In order to achieve a full outer shell, it just needs to share 1 electron with hydrogen. And if we then look at hydrogen, hydrogen has 1 electron in its outer shell. It's in group 1, it only has 1 shell anyway, and therefore hydrogen will need to attract 1 more electron to gain a full outer shell of 2, because don't forget in any electron configuration the first shell can take a maximum of 2 electrons. If we then have a look at plotting our electrons, the question specifically says use dots and crosses. So make sure you use crosses for one and dots for the other. And they have already allocated crosses for chlorine. So start off with plotting the electrons for your chlorine. They've already put 2, 4 in, so 5, 6, and that one electron that it needs to share with hydrogen we need to put in the space between where the circles overlap. And then of course hydrogen just needs one electron that it's going to share from chlorine, which we've already got in there, and we'll go ahead and plot our one electron that hydrogen has. Don't forget to do it as a dot, and then we've shown our covalent bond. And if we just add up then to double check, we can see that chlorine has 2, 4, 6, 8. And we can also see, if we double check with the hydrogen, hydrogen then has 2 here in its outer shell. And we've shown that both of the atoms then have the full outer shell. Finally, remember there are strong forces of attraction between the atoms in a covalent bond, but in small covalent molecules there are weak intermolecular forces of attraction, and that's why a lot of them are gases at room temperature. And of course that affects their melting points and their boiling points. And of course, remember that the explanation is weak forces of attraction between the molecules. I hope this video has been helpful, and finally I'd just like to say good luck tomorrow.